Hi everyone, welcome to the second lesson for topic 3.2 Growth and Decay in Sequences. So for this lesson, we are going to look at the first type of special sequence that we have, which is known as the arithmetic sequence. Okay, so if you took XPM mathematics before, then you should be quite familiar with this term already. Okay, so there are two learning outcomes that we need to achieve for today's lesson. So the first one is you need to know how to use recursion to generate an arithmetic sequence. So I hope that you still remember what a recursion rule is from the previous lesson. Then the second one is how can we deduce a rule for the nth term for a particular arithmetic sequence. And we are going to use this rule to actually make some prediction, like if let's say in your sequence you are given from the first term to the fifth term, then how can you actually straight away jump to and know what is the 50th term. Okay, so that's the idea for today. It will be more on the calculation part, so I wish to cover all the theoretical part first, then after that we'll move on to the application part. Okay, so let's start with a quick recap on what we have just learned in our last lesson. Okay, so in the first lesson we have known that a sequence is actually an order list of number. So yeah, it can be object as well, but in this particular syllabus, we are talking about only numbers, right? Then after that, we can actually generate a equation that can actually tell us that what is the next term by using the previous term. So which recursively defines a sequence. So the equation that we use is actually called as the recurrence relation. Okay, so the word recurse actually means repeat. So which means that when you repetitively use your previous term, then you will be able to get the subsequent term. Or this is also known as the recursive rule. Or if you see like recursion, that means the same thing as well. So you can just remember the word recurse. Okay, so for today's session, let's start with arithmetic sequence. Okay, an arithmetic sequence is a sequence of numbers such that the difference, okay, so the keyword here is the difference, okay, between any two successive member of the sequence is constant. So which means no matter you are using which term, as long as you use to minus the previous term, then you should be able to get the same number. Okay, so how is arithmetic sequence form is actually by adding or subtracting. But normally we only say that it's adding lah, because subtracting we can try to treat it as adding a negative number, right? So that's why in the general formula we try to use plus instead of like minus, because plus minus then you are getting a minus as well. So that's why we are treating subtracting as adding a negative number. Okay, so the constant number that we add or subtract to get the preceding term is actually known as the common difference. Okay, because they are having the difference which is the same, so that's why the difference is common, right? So it's called as common difference, denoted by the symbol D. Okay, so when we try to describe an arithmetic sequence, there are two elements that we need to determine. So it's the same thing like in recursive rule. There are two things that you need when you try to write the recursion. So it will be the rule itself and also the initial term, right? So it's the same thing here. So the rule itself, because it's already a arithmetic sequence, so that's why the rule, or so-called like the thing that we need to determine here, will be the common difference. So that's the first thing. You will need to know what is the number that we constantly add or constantly minus. Then after that, the second one is the same, which is the initial term. Okay, so initial term denoted as A. So common difference is T. So you can just remember the alphabet A, B, C, D, E, right? So A is like the first alphabet as well. So that's why we use A to denote initial term. Okay, so let's start with a very easy example. Okay, example 1, continue the sequence, determine the initial term and the common difference for the sequence. So use our prior knowledge in lesson 1, then we try to form a recursive rule. Okay, so in this term, then you can find out that there's a common difference between all the terms. So you can see when you use 5 to minus 2, then you are getting 3, am I right? So which means that how do you get 5 from 2 is actually by adding 3. So how do you get 8 from 5 is actually adding another 3. So it will be a continuous process. So which means after 14, then we can add 3 and we can get the next term, which is going to be 17. Add another 3, then it's going to be 20. Okay, so in this term, you can see that your initial term is basically 2, and what is your common difference? Is just positive 3. So when we try to write down what's our recursive rule is, so it will be to find the nth term, I will use the previous term and then plus the common difference, right, which is 3 in this case. So we try to write down our initial term as well, t1 equals to 2. So you must make sure, yeah, so a recursive rule without the initial term is not a complete one. Okay, let's look at the last one. So when you try to find out the common difference, same thing, we try to use any term minus the previous term. So 65 minus 80, then you can get negative 15. So which means that for us to get 65 after 80, then it will be minus 15. And we continue to minus 15 for each term. Okay, so after 20 minus 15, then we can get 5. Okay, so after 5 minus another 15, so that's negative 10. Okay, so in this case, we have our initial term is equal to 80, and then the common difference is equal to negative 15. Okay, so it's very important for you to identify whether it's positive or negative, yeah, because if let's say your common difference is a negative, you can see the number decreasing. If let's say your common difference is a positive one, you can see the sequence actually increasing. Okay, so recursion. So to find the n term, we use the previous term, which is the n minus 1 term, to minus 15. Okay, so in this case, then we can get our initial term as 80. Okay, now let's move on to the next part of the notes. Okay, so you will realize that for arithmetic sequence, right, it has a general pattern. So how do you get the next term is by adding a common difference to the previous term, right? So we start with an initial term, which is A, then you plus another common difference. When you reach a third term, then from the second term, you plus another D, and so on for the rest of the term. So which means that in general, we can say that what is the recurrence relation for an arithmetic sequence? It will be how do we get the current term is by using the previous term and then plus the common difference. Okay, and our T1 is just basically A, which is the initial term for this sequence. So A is the initial term, and then D is the common difference. Okay, so which means is like what I mentioned just now. So how do you get the each subsequent term is by adding D to the previous term. So there are two different situations. So the first one is if let's say your D is a positive number, then which means the sequence that you are going to get is going to be a increasing sequence, right? Because you can see if let's say your D is a positive number, when you add up, the number will become bigger and bigger, right? So in the other words, if let's say the D is a negative number, which means you are like adding a negative number, so it eventually become like subtracting a number, so that's why the sequence will become smaller and smaller, and that's decreasing. Okay, so let's move on to example 2. Okay, example 2, identify if the following recurrence relations generate a arithmetic sequence or not. Okay, so it can actually refer to what we have just now. So we know that for all arithmetic sequence, they will have a general recurrence relation that is Tn equals to Tn minus 1 and plus D. Okay, so let's look at A. So how do you get the current term? You use the previous term and plus 3, right? So this is basically the same thing like what we have in general. So that's why you know that is a yes. Okay, so the common difference here is basically 3. So if you were to write out the recurrence relation, then it will be your 4, right? Then after that, plus 3, plus another 3, plus another 3, and so on. Okay, now B. So same thing. So but now the question is given in n plus 1 term and the n term. So in this case, it's the same thing. So how do you get the future term? You get your current term at minus 7, right? So that's why it's a yes as well. And the common difference here is negative 7. So we have 79, 72, and then 65, 58, and so on. Okay, so C Tn equals to 4, the n minus 1 term. Okay, so as you can see, when you try to compare to this one, you can see a difference here. So how do you get the next term? You plus a common difference. But for this one, what happened is you multiply. So that's why in this case, it's a no, because there will no be a common difference, but this is common ratio that we will be discussing in the next lesson. So in this case, then we will have 2 and multiply 4, so we have 8, 32, and then multiply another 4, then we'll get 148, and so on. Okay, so that's the idea. Okay, so now let's move on. So D. Okay, 1, 8. Sorry, I think I did make some mistake here. So 1, 2, 8. Yeah. Okay, so D. So how do you get the next term? You use the previous term and then you plus 5. Okay, so this is just some rearrangement of your term. So instead of writing Tn plus 5, they write 5 plus Tn. But the idea is the same, right? No matter you are saying A plus B or B plus A, they are just the same thing. So in this case, it's a yes as well. So when you write down the sequence, right, you'll realize that your term 1 start from 11, so you plus your term 1 to get your term 2, right? So 16, 21, 26, and move on. Okay, so E. So you can see that there's a plus 2 as well, but then the term itself, you multiply for and only you plus 2. So that's why in this case, there's a no. So you must remember for AP, it must be like plus D only, you cannot multiply anything. So you can try to substitute and see what do you get. So your first term is 5, right? Sorry, this is supposed to be T1. Okay, so your first term start from 5, then you multiply by 4 and plus 2. So this is how we get 22. Then again, 22. So we multiply 4 and plus 2, so we get 90. So 90 multiply 4, we get 360 plus 2, so that's 362. Okay, so as you can see, the difference between all the term is actually different, so that's why it's not an AP. Okay, so example 3. Okay, example 3, for each of the following sequences, state whether the sequence is an arithmetic sequence or not. So for those that are, state the initial term, the common difference, and the recursive formula. Okay, so in this term, you need to identify yourself. So the first one, you can see that the difference that you can see when you use the next term to minus the previous term is always the same, right? So 42 minus 50 is the same with 34 minus 42, and so on. Okay, so you can see there's a common difference here, so that's why it's a yes. Okay, so remember to check everything else. So even 18 minus 26, 26 minus 34, make sure everything give you the same answer. So A is 50. The common difference here is negative 8. Okay, so remember negative is important. Okay, so write down the recursive rule. So we have Tn will be equal to the previous term and then minus 8. Okay, and our first term in this case, sorry, T1, it will be equal to 50. Okay, so now part B, 3, 6, 12, 24, 48, 96. So you'll realize here that, I mean, it is a sequence, but then how do they get the sequence is that they're multiplied, am I right? So that's why it's not a common difference here. So that's why the idea is no. So because there is no common difference. Okay, then after that, C, 1, and then 3.5, 6, 2.5, 11. So you can try to use your calculator and help you to check out, or actually mental calculation, you should be able to do that as well. So when you use all the next term to minus the previous term, you'll be able to get negative 2.5. Sorry, positive, because you add up 2.5, right? So this is a yes. Okay, so the A in this case is 1. The common difference is 2.5. So the recursive in this term is the previous term and we plus 2.5. Okay. So for AP, right, it doesn't has to be always a whole number that you try to plus or minus. It can be even fraction or like decimal as well. So your T1 is equals to 1. Okay, so example 4. Okay, example 4, given an arithmetic sequence, the fifth term is 25 and the common difference is 4. So question 1 is to find out the first 3 term in the sequence. Okay, so this is not difficult, right? As long as you understand what an arithmetic sequence is. So imagine that we have term 1, term 2, term 3, term 4, and term 5. Okay, so if let's say the arithmetic sequence for the fifth term is 25, so how do you get your next term is actually by the common difference, which is negative 4, right? So you imagine how can you get back the previous number? Then you need to do the reverse process, right? So that's why plus 4. So we have the number of 29. Then the same thing, we try to plus 4 to get the third term. So we have 33 plus another 4, so 37 plus another 4, then it will be 41. Okay, so this is how do we get our first 3 terms, so which is going to be 41, 37, and 33. So you can always try to check and see when you try to go on to an ascending order, is it going to give you -4? So 37 minus 41, you got -4. 33 minus 37, you got -4 as well. Okay. B, state the recurrence relation. So this is easy. So to find the n term, you use the n minus 1 term and then minus 4. Okay. And don't forget to state your first term, which is 41. Okay. So example 5. Okay, the sixth term in an arithmetic sequence is 8 and the first term is 348. Okay, so which means we will have our T1 here as 348. After that, we have T2, T3, T4, T5, and after that, we are given the T6, which is 8. Okay, so question one is to find out the common difference. So later when we try to learn the general rule, then you can use equation to solve. So in this case, we can try to use more on a common sense to solve this. So from first term to the sixth term, you know that that's going to be 1D, 2D, 3, 4, and 5. Am I right? So the 5D actually contribute from 348 to 8. So which means that you can always write that 348 will need to plus 5D, then only equals to 8. Am I right? 1, 2, 3, 4, 5. That's 5D that you add on 348 to get 8. So that's why 5D will be equal to negative 340. So that's why D will be equal to negative 68. Okay, so just by doing this, then you have your answer. So now let's move on to B. So the recurrence relation, so the n term is equal to the previous term and minus 68. So and you already got your first term, which is 348. Okay, so just like that, I hope that you can get the idea. So now let's move on to the last part for the notes, which we discussed about the derivation of the general formula of an arithmetic sequence. Okay, now we'll be deriving the general formula for arithmetic sequence. Okay, so yeah, that's the rule to help us to find any general term in an arithmetic sequence. So this is called as the general formula, or sometimes we also call it as the n term rule. Okay, so the n term, so which means it's the Tn that we always wrote. So the n term rule for an arithmetic sequence. Okay, so let's try to see how this formula is derived first. So you can see that this sequence is an arithmetic sequence, right? So there's a common difference of positive 3 for every term here. So let's try to see. So we have the first term as the number of 5. So the second term we have 8. So how do we obtain 8? It's actually from 5 plus 3, right? Then after that, how do we get 11? It's actually from 5 and then you plus 2 times of 3, right? So which is 5 plus 3, then you plus another 3. Then the same thing, when you go to the fourth term, then it will be 5 plus 3 and plus 3. This is how you get 14, right? So now let's try to simplify what we have here. So for the second term, right, actually what you are trying to do here is you use the initial term and you plus 1 times of 3. So how do you get the third term? You actually use the initial term and you plus 2 times of 3. So how do you get the fourth term? It's actually from the initial term and you plus 3 times of 3. So for the first one, it's actually 5 plus 0 times of 3. Am I right? So this is how you get back to the initial term, which is 5. Okay, now I want you to imagine what's the relationship that you can see here. So you can definitely see that all this term, how do you obtain the next term is starting with the initial term. Am I right? So that's why if let's say I wish to find out the 50 and the 100 term, I will start with the initial term. Okay, so the difference of the number here is the number that how many times of the difference we add into the initial term. Am I right? So the 3 here are all the common difference. So if let's say I were to find the first term, that I plus 0 times of 3. If I were to find the second term, I plus 1 times of 3. If I were to find the third term, then I plus 2 times of 3. So can you see the pattern here? So 1 time of 3 is like 2 minus 1, then you get 1. So how do you get 2? It's actually 3 minus 1, then you get 2. So to get the fourth term, then you plus 3 times of 3. So that's why if let's say you wish to find 50th term, then which means that you will actually use 5 plus 49 times of 3. So this is how we can get the 50 term. If you wish to find the 100th term, then you will plus 99 times of the common difference, which is 3. Okay, so let's try to write down the general formula for this. If let's say I wish to find the n term, actually what do I do is I just use the initial term plus the n minus 1 times of my d here, which is 3. Am I right? So for example, if let's say I want to find the 200 term, then I just substitute 200 minus 1, then plus 199 times of 3, right? So that's the idea. Okay, so now let's try to look at it in a much more general approach. So if let's say we are now not talking about the initial term, which is 5 and the common difference 3, but we are looking at it as a general approach. So which means if let's say I start with an initial term with a, so how do I get the second term? I actually use a plus d, right? That actually give me a plus 1 times of d. So how do I get the third term? I actually plus another d to my second term, right? So that's why it will become a plus d, which eventually is a plus 2 times of d, right? So when I move on to the next one, then I plus another t to the third term, and that give me a plus 3 times of d. Okay, so now if I wish to find out the 50 term, then which means that I will use a plus how many times of d? It should be 49 times of d, right? Then if let's say it's 100 term, then it will be a plus 99 times of d. So if let's say we try to write this in a general term which representing n term, then it will be we use the initial term plus, then you need to plus certain times of d, right? What's the certain times? It will be the number that you have, then minus 1, right? So n minus 1. So this is the rule of n term for our arithmetic sequence. So which is written as Tn is equal to a plus n minus 1d. So where what's our a is the initial term, and what is the d is basically the common difference. So you must make sure that it can be positive or negative, depends on your sequence. So yeah, need to check properly, is your sequence decreasing or increasing. So the n term rule allow us to jump to any desired term without determining all the preceding term. So if you can recall, right, when we talk about recursive rule, we're actually relating our n term to the n minus 1 term. Am I right? So recursive rule meaning like how this formula help you to actually get all the number recurs, right? So which means that you actually need T1 to tell you T2. You need T2 to tell you about T3. And you need the 10th term to help tell you about the 11th term. So that's why for recursive rule, you can't actually jump to any term that you want. So which means that if let's say you wish to find the 100th term, you need to do everything up to until you get the 99th term, then only you can find the 100th term. But by using the general formula, right, we are now expressing our n term in terms of n. So which means that as long as you know what is the position of the term that you want to find, then we can try to find out what's the value. Okay, so which means, for example, by looking at this, if let's say I want to find the 45 term, then my position is 45. So I only need to know my n is 45, then I will be able to find out what is the term at the place there. Okay, so now we'll be looking at some examples so that you can understand better for the idea. Okay, so let's continue with the example. Alright, example 6, state the initial term and the common difference for each of the arithmetic sequence, then find out what's the fourth term, the 30th term, and the 100th term. Okay, so let's start with to find out what's the n term rule first. So for the first one, then you have initial term, which denoted by a, right? So a is given 50, so that's our initial term, and our d, you can just use any term, then you minus the previous term so that you can get your d, right? So you can just get anything like 41 minus 44, then that give you negative 3. Okay, so after you get the answer, then normally you will need to better check. So for example, you are getting a negative number, then you should be seeing that your arithmetic sequence is a decreasing one. If it's an increasing one but you get a negative d, then you know something wrong there already. Okay, so now let's try to write down our n term rule here. So Tn is equal to a plus n minus 1d, right? It doesn't matter you are writing your t in a big capital letter or in a small letter, it just means the same thing. Like what I say is just a letter, right? If you want to use like pn also can, but normally we talk about like n terms, so that's why t. Okay, so now substitute the number that we have. So a is 50, okay, and then n minus 1, our common difference here is negative 3. Okay, so make sure that you need to expand until you get a simplified answer. So in this case, then we have 50. So when you expand n times negative 3, so we have negative 3n. So negative 1 times negative 3, we have plus 3. Okay, so in this case, then we can get 53 minus 3n. Okay, so after we get the n term rule, then now we can actually start to find what's our term here. So for example, we need to find the fourth term. Okay, so what do we need to do is just substitute n into our formula here. So that's why you are finding the fourth term, right? So now your n is 4. So we are just changing the n to 4. So 53 minus 3 times 4. Okay, so that gives us 53 minus 12, and that is 41. Okay, so after we get this, then now we continue to get the 30 term. So T30. So now our n is 30, right? So that's why 53 minus 3 times 30. So 3 times 30 gives us 90. So 53 minus 90, that's negative 37. Okay, so move on, the 100 term. So 53 minus 3 and then 100. Okay, so 53 minus 300, that's negative 247. Okay, so I hope that that's not too hard for now. Yeah, so basically you just build, oh, what's your n term, then after that you can just substitute the number that you need. Okay, so now let's try to look at part B. Okay, so n plus 1 term is obtained by the n term plus 4. Okay, so from the recursive rule here, you can see that this is an arithmetic sequence as well. So that's why your initial term is your T1. So A is 15. Okay, then after that, let's continue with the D. So you can see that how do you get the next term? You use the previous term to plus 4, right? So that's why your common difference here is positive 4. So now same thing, Tn is equal to A plus n minus 1D. Sorry, in this case, since they use the capital letter, that I should do capital letter as well. Okay, so Tn. All right, so now substitute our A is 15, n minus 1, d is 4. Okay, so we can have 15 plus 4n minus 4. Okay, so when we write it, then we can write 4n plus 11. Okay, so it doesn't matter that you write 11 plus 4n or 4n plus 11, like a plus b or b plus a is just the same thing, so it's your own preference. Yeah, but for me normally if let's say there's a negative, right, then I'll choose to write at the back, then I choose to write number at the first. So in this case then, which means both are positive, then it's good that we write the one with variable in front, right? So normally that's like how we do, but it doesn't really matter. Okay, so now let's continue to find our term. Okay, so let's start with the fourth term will be equal to 4 and then multiply with 4 plus 11. Okay, so that's 16 plus 11, so 27. So when we move on, so to find the 30 term, so 4, 30 plus 11. So we have 120 plus 11, that's 131. Then after that, we move on, T100. So 4 times 100 and then plus 11, that gives us 411. Okay, so after you get this value, then you should be able to see that the value here should be a number that's larger than 15, right? So if let's say you get a number that's like smaller than 15, then you know something is wrong because your common difference is positive 4. So you should get something that's like positive, right? Okay, so now we move on to C. So this is a part that I want to introduce to you. How do you use your calculator to solve? Okay, but let's generate our n term rule first. So how do you get the next term is by using the previous term, then you minus 7. So that's why the initial is 25. Okay, and the common difference here is negative 7. So Tn equal to a plus n minus 1d. So we have our a as 25 n minus 1, and then our common difference is negative 7. So we have 25 minus 7n plus 7. So that gives us 32 minus 7n. Okay, so now let's see how can we use our calculator to help us to generate it. Okay, so you should have your calculator with you. So yeah, let's add a list and spreadsheet. Okay, so now I will show you like two different type of method to actually type it. So the first one is the one that I actually prefer the most, which is by using the sequence generator in our TI Inspire. But then just to let you know, when we go to finance, then you still need to know how to do it like manually, like how to connect with the cell thing. So that's why I'll just show you both, but then it depends on you like which one you prefer. Okay, so let's try to look at the equation that we have. So I'll show you first how do we generate the recursive one. So this is the recursive. Okay, so you can go to menu and then data. Then you can see that something that's generate sequence. Menu data generate sequence. So menu 3 1. So after you press generate sequence, right, it will come out something like this. So the question, sorry, the tab here will actually ask you what is the formula for your UN. So you can imagine what we have here is TN. So it's the same thing, like it's just a change of alphabet from T to U. Then after that, what they want is you key in a formula to tell them how do they generate a formula for the UN. Okay, so what do we need to do is, since this is U, the N term as well, but they try to write the letter of U, so that's why we need to use U also. So U, then bracket N minus 1. So I hope that you still remember. So I tell you that previously, so no matter you are using TN, N as a subscript, or you try to write your N in a bracket, they are actually the same thing. So it's the same thing here. So you see, I didn't change anything. It's just that the calculator requires us to use U instead of T. Then after that, what do you need to do? Minus 7. Okay, so what's the initial term here? You are given the T1 is 25, right? So you just type in 25. Okay, so n0 is like what's the first n that you want to put in. So normally we start with the first term, so we don't really change it. So you just leave it as 1. Then the n maximum is how many term that you want to generate. So if let's say you want to generate until 1000, then you just put it. Or you just want to like try out whether million words works or not. So you try out, but there are varies that your calculator might be lag. Okay, so normally you just don't change. So ceiling value. So if let's say you wish that you only generate your sequence until the maximum value, which is like 100, then you stop, then you put in your ceiling value. But normally you just don't care about that. So you just okay. Okay, then you actually see the whole sequence actually come out here. So you can see that the first term 25, right? Minus 7, you get 18, minus 7, you get 11, minus 7, you get 4, and so on. Okay, so this is the recursive. Okay, so now let's try to see if let's say we want to use the n term rule, can we do that? Yes, we can also. So this is our recursive rule, right? So the same thing, menu, data, generate sequence. Okay, but when you key in here, we do not use the recursive, so that's why we are not using UN minus 1, but in this case, we only use n. So that's why I just type in 32 minus 7n. Okay, so your initial term is your A, so which is the same, which is 25, right? Then after that, the other thing we don't change, then okay. So you'll see you generate the exactly same thing as well, although you are using the n term rule. Okay, so yeah, they are just the same thing, which means what you derive here is correct. Then we can straight away get our answer from the calculator here. So the question need our T4, right? So you can see T4 is 4. Okay, and then after that, what's our T30? Then we can move on to 30. Yeah, so you can see T30 is negative 178. Then after that, T100, so you just scroll until the until you get 100 terms, so you get negative 668. Okay, so if you wish to try, then you can always try out with your, try out with the formula that you got, then you substitute and see whether you get the same answer or not. Okay, so now I'm going to show you the other, which is like much more manually. Normally, I don't really prefer this method, but this is another thing that you can do, especially for recursive. Okay, so what you can try to do here is for a C term, then you just key in your initial value, which is going to be 25. Okay, So after you key in your first value, right, then what you need to do is, for every next term, you will need to minus 7. Am I right? So that's why, how do you get the second term? Is actually equal to your first term, which is 25. So you need to check where is 25. So you can go to 25 and you'll see that C1. So this is like the cell in the column C and the row 1. So that's why in this case, it will be equal to your C1, then minus 7. Is it okay? Then just press enter. Then you will get it in as well. Then after that, what do we need to do? You can imagine everything is like just recurse, right? So that's why you go to 18. Then after that, with the help with your calculator, so menu, data, and then go to fill. Okay, menu 3, menu data fill. Then after that, you can go down. Then you will see it will actually, it will actually go down. Then it will actually come out something like this. So like the dotted line. So you just continue to press your calculator until you get the term that you want. So yeah, when you have compared to a previously, maybe you need more, manually operation here, but it will be helpful in the unit 4 when we move on to financial, so you still need to know this. Okay, now for example, when you reach 100 at 1, and just enter, then the calculator will show everything. So you see all the sequence is actually the same thing. Okay, so these are the two ways that you can try to use, like if you wish to use your calculator to help you to solve. But you still need to know how to do the manual calculation instead, in the case where if the question come out in your calculator free paper, then you can't use your calculator to help you to do this. Negative 178. So just now we got the T 100, right? Okay, so you can always try out by substituting this, then you get the exactly same thing as well. Okay, so now let's go to the last one. So the term starts with 1, each term obtained by adding 6 to the previous term. Okay, so by the description here, and you will know that the recursive rule is by adding 6 to the previous term, right? So that's why the initial term is 1. Okay, and what's the rule here is by adding 6. So that's why the common difference is 6. So now let's try to find the end term. So Tn equal to A plus n minus 1d. Okay, then after that substitute 1, n minus 1, and then 6. Okay, and from here we get 1 plus 6n minus 6, and that gives us 6n minus 5. Okay, so same thing, you can try out your calculator, or you can just substitute and you can get your answer. 5, that's 19. 630 minus 5, so you get 175. T 100, so 6 times 100 minus 5, and we can get 595. Okay, so that's pretty much for this very simple example. So now we move on to 7. Alright, example 7. For the arithmetic sequence 28, 32, 36, 40, find an expression for the nth term and also find out which term is equal to 100. Okay, so now let's try to find out the expression for the nth term first. So as we can see here, the sequence we having the initial term as 28. Okay, and the common difference here is positive 4. So Tn equal to A plus n minus 1d. So the A that we have is 28 plus n minus 1. The common difference here is 4, right? So let's simplify this. So 28 plus 4n minus 4, and that gives us 4n plus 24. Okay, so after we got this, then now we can proceed. So we want to find out which term is equal to 100. So which means that our term is equal to 100, and we want to find out which is the term, right? So which means that we are finding n, and our term is the 100 here. So that's why substitute what is Tn is 4n plus 24. So by using solving, then you'll be able to get 4n is equal to 76, and that gives us n equal to 19. Okay, so which means we know that the 19 term is equal to 100. Alright, so now let's look at example 8. Alright, so this is similar with example 7. So for this arithmetic sequence, then we find out the nth term first. So we can have the initial term is negative 189. So the common difference, yeah, so remember when you see this, right, it's actually become larger and larger. So make sure that your common difference doesn't have negative, okay? So it should be negative 180 minus negative 189. So you use any term minus the previous term to get the common difference, right? So that's why we can say it's positive 9. So after we got this, then now the n term is equal to a plus n minus 1d. So a is negative 189 plus n minus 1, the d is 9. So let's expand it, plus 9n minus 9. So we have 9n minus 198. Okay, so this is what we got. So now we can proceed to find what's equals to 0. So which term equals to 0? Same thing. So our n term is equal to 0 and we want to find out what is the n, right? So that's why 9n minus 189 equals to 0. So we can get 9n equals to 198. So that gives us n is equal to 22. So that's why in this case, we have the 22nd term is equal to 0. Okay, so now let's see how can we use our calculator to help us to solve this. Okay, so we can try to generate the sequence for this. So since we already had the n term rule, right? So now let's generate the sequence. Okay, so menu, data, and then generate sequence, right? If you wish to use the manual one, also can. So in this case, then we have 9n minus 198. So after you got this, then the initial term is negative 189. So you just type everything, then okay. So after you get your answer, then you scroll down, then you should be able to get the term which is equal to 0. As what you can see here is the 22nd term. So that's why it's aligned with our answer. The 22nd term is actually 0. Okay, so yeah, you can use your calculator to help you to solve that. But I mean, if let's say it's a calculator free paper, then you need to know how to do it by manual calculation, right? Okay, so now example 9. Okay, example 9, for the arithmetic sequence 11, 14, 17, 20, determine which term of the sequence is the first one to exceed 300 and state the number. Okay, so same thing, let's try to find out what's our n term first. So the a here is 11 and the common difference here is 3. So that's obvious, right? 14 minus 11, you get positive 3. So Tn equal to a plus n minus 1d. Okay, so the a here we have 11, then a minus 1, the d is 3, so let's expand it. So 11 plus 3n minus 3, and that gives us 3n plus 8. Okay, so after we got this, then the question 1, which term of the sequence is the first to exceed 300? So which means which is the first term that becomes greater than 300? So which means that what is the term that greater than 300? Okay, so now Tn is equals to 3n plus 8, right? Then we can try to solve it. Then we can get 3n will be greater than 300 minus 8. Then that gives us 292. And n is greater than 97.3. So we want to find out what's the first term. Okay, the first one exceeds 300. So that's why the minimum n that is the first number that greater than 97, it should be 98. Okay, so this is like the position, so which means the 98 term is the first term that exceeds 300. So the question also wants us to state the number. So for the 98 term, equal to 3 multiply 98 and plus 8. Okay, and from the calculation, then we can get 4, so that's why it's 302. So that's why in a logical sense, you can try to imagine if the 98 term is 302, then which means the 97 term, it will be 299, right? Because it will minus 3. So that's why 302 should be the first term that exceeds 300. Okay, so similarly, you can also use your calculator to help you to check your answer. So menu, data, generate sequence. So this is 3n plus 8, right? And our first term here, sorry for that, 3n plus 8. Then our initial term here is actually 11. Okay, so you just type everything then. Okay, so you can just scroll down. then you should be able to see that the number is like all increasing, right? Until you get the first number that exceeds 300 and you should be able to get 98. Okay, so that's why you can see the 98 term is 302 and the 97 term is 299. So from here, then you know that your answer is correct. Okay, so let's move on to example 10. Okay, example 10, find the 20th term of an arithmetic sequence for which the third term is 2 and the 10th term is negative 12. Okay, so for this question, I will show you two methods, but there'll be like, I mean, both are correct. It's just your own preference, but personally, I will encourage you to go for method 2 for the simultaneous equation because that would be much more mathematical approach. Okay, so let's try to see the method 1. So what we can try to do here is you already know that what is your third term and also your 10th term, right? So you can actually, so T3 is 2 and then T10 is negative 12. So you can actually try to imagine, so you have T4, T5, T6, T7, T8, T9, so until T10. So you can actually imagine that T4, T5, 6, 7, 8, 9, 10. So that will be 1D, 2D, 3D, 4, 5, 6, 7. It will be 7D until from the third term to the 10th term. So which means that T3 actually you plus another 7D and you can get T10. Okay, I guess that's like very, I mean, just by using the common sense lah. So that's why the third term that we have is actually 2 and then plus 7D equals to the 10th term, which is negative 12. So we can have 7D is equal to move this to the other side, then we have negative 14 and that gives us the D is negative 2. Okay, so after we got this, then now you can try to substitute back into, if let's say our T3 is A plus n minus 1D, right? So which means in this case, the third term is 2 and we can get the A. So n minus 1, so the n here is 3, so that's why 3 minus 1 and D is negative 2. Okay, so we got 2 equal to A plus, so 3 minus 1 is 2, so that's negative 4. So that gives us our A is actually equal to 6. Okay, so after we got this, then now you can actually find out what's your T20. I use different colors. Sorry, I should actually start from here. But yeah, doesn't matter. So T20, okay, will be equal to A plus n minus 1, right? So A is 6 plus n minus 1, so 20 minus 1, and the common difference is negative 2. Okay, so you can just expand it, then we can get 6 plus 19 times negative 2, and that gives us negative 32. Okay, so this is method 1. So which means you use a much more common sense to find what's your D than you use your formula to find your A. So even for your A, if let's say you don't want to use the formula, also can, like, you know, the third term, right? So for you to get the first term, then what you need to do, you reverse. So instead of like plus a 2D, then which means you'll kind of like go to the reverse part and minus 2D, then you can get your T1. Okay, so yeah, that's the idea on how you can solve this. So the second one, I would say this will be a uh much more mathematical approach, which in this case, then what we try to do is we form simultaneous equation. So in this case, we have Tn is equal to A plus n minus 1D, right? So that's why from the question here, we know that T3 is equal to 2. So in other words, I know that for the third term, I should be using A plus n minus 1 is 3 minus 1, right? Then the difference and equals to 2. So from here, then I can get A plus 2D is equal to 2. So that's my first equation. So after I get this, then I'll move on to the next one is I'm given the 10th term is negative 12. So that's why same thing, A plus n minus 1, which is 10 minus 1D will be equal to negative 12. So from here, then I can get A plus 9D is equal to negative 12. So that's the second equation. Okay, so after I get this, then what do I need to do is I just solve simultaneous equation lah. So I'll be using the second equation to minus off the first equation, and that gives me 7D equals to negative 12 minus 2. And I can get 7D is actually negative 14. Okay, then D is negative 2. Then after that, I substitute back into the equation 1. So I can have a plus 2d is negative 2 equals to 2. So from here, I get my a is 6. So you can see the answer is actually the same. But the different idea is that I use formula to solve rather than like using a much more common sense of thing. So after I get this, then now I can find out what's my 20th term. So T20 is equal to A plus N minus 1D. So is 20 minus 1 and the D is negative 2. Okay, so you can see it's exactly the same like what we have in the first method and you got this answer. Okay, so just a very quick one. So actually, if you have your calculator, right, your calculator can help you to solve this. So that's why after you get these two equation, then you can actually use your calculator to solve. If let's say this question come out in your calculator assume paper. Okay, so let's see how can we do that. Okay, so you can open a new page, right? Then after that, go to add calculator. So after you add calculator, then go to menu and then algebra. Then you can see, sorry, let me try to, okay, algebra. So this is actually linear simultaneous equation. So you can go to solve system of equation that's come out too. So I think both works, but in this case, if you already know that it's linear, which means that for all your variable there's no power, then you can use system of linear equation to solve. So in this case, you have two variable. Okay, number of equation is also 2. The two variables that you have here is a and d. So you just put in a and d, then okay. So the calculator will show you this. Then now what we need to do is just type in the equation here. So that's why a plus, so 2d, right? So remember it's 2 times d. Okay, and it will be equal to 2. Okay, so that's our first equation. So after that, then you just go down, then you press the second equation. So 2 plus 9, and then d, same thing. Oops, sorry. So multiply d. Okay, then that will give us equal to negative 12. So negative 12. Okay, so after we got this, then you just enter. Then the calculator will actually show you the two numbers. So the first one is like what's the first variable here, so which is a. So that's why a is equals to 6. Then after that, d is equals to negative 2. Okay, so you see you get the exactly same thing like what we got here lah. So a is 6, then d is negative 2. Then you use your answer to substitute back into the equation, then we can get the answer. Okay, so I think that's pretty simple. So let's look at the last example here. Okay, find the 22nd term of an arithmetic sequence in which the 50th term is 209 and the 61st term is 253. Okay, so yeah, this is the similar question with example 10. So I'm just going to use simultaneous to solve this. So T50 is equal to 209. So that's why a plus n minus 1d, right? So a plus n minus 1, 50 minus 1d is equal to 209. So that gives us a plus 49d is equal to 209. Okay, so now move on to the second one. T61 is 253. So a plus, same thing, if you already know like n minus 1d, then it's going to be 60d lah. But yeah, let's try to just write down everything incomplete. So a plus 60d will be equal to 253. So that's our second equation. Okay, so after we got this, then now we can move on. So you can try to solve this. So it's 2 minus 1 as well. So you can see 60d minus 49d. Okay, so I hope that you know how to do simultaneous, right? A minus A, you get 0, so that's why you don't need to write that. Sorry, this is minus. Then equal to 253 minus 209. So 60 minus 49 is 11d, then equal to, for this part, we have 44. Okay, so after we know this, then we know that our d is equal to positive 4. So which is correct because you can see that the term actually is increasing. Like compared to your 50 term, the 61 term is actually larger than your 15 term. So after we got this answer for this question, we actually do not really need to get our A because the question wants the 62nd term. So which we already have our 61st term, right? So that's why T62 will just equal to the T61 and then plus the D. So that's why is 253 and then plus the D here is 4. Then from here we can get 257. Okay, so same thing, you can try to use your calculator to see whether so it's going to be the same thing here. So yeah, you can still use the linear so solve equation, so linear. Okay, then in this case same thing, we can try to put 2, then after that is A and D also. So okay, so key in our equation. So A plus 49D is equal to 209. Then after that A plus, oops, sorry for that. A plus 60D is equal to 253. Okay, then after that just enter, then you will see 13 and 4. So that's why it's aligned to our answer 4 here. Okay, so that's pretty much for this lesson. So I hope that you can understand. If let's say you have any question, then feel free to just personally message me. So make sure that you know what is arithmetic sequence and what is geometric sequence. Then after you come back from the holiday, then we'll actually start to deal with the application part. All right, so thanks for watching. See you.